Hello, I'm Scholastic Sam. Welcome back to another one of my math and science videos. Today in Algebra 2 Lesson 1.3, we will be learning about quadratic functions. Now, first, because I don't want to have a whole separate video for it, we're going to go over linear functions. Now, we know it's in slope-intercept form. We'll probably go over the point form, but for now we're just doing slope-intercept form. We have y equals the slope plus the y-intercept. So b is the y-intercept where it intersects with the y-axis, and b is the change in height over the change in y over the change in x, or rise over run. So if you see a point where it goes up 6, or it goes up 3 and over 2, like up 3 into the right 2, you know the slope is 3 over 2, or 1.5. And then if you see that same one intersects the y-axis at 1, you know the formula is y equals 3/2 x plus 1. Now we'll show an example of that in Desmos later. Now we're going to go on to quadratic functions. The formula is y equals a x minus h squared plus k. Now you usually won't have all of these variables, but I'm going to go over all of them just in case you do. Now, a negative a, I got questions about this. A negative a it says x-axis. A negative a does not reflect it over the x-axis. It reflects it over the vertex. Now, the vertex is the point where the two sides, the negative side and the positive side of the quadratic function meet. And if it's negative, it just reflects over that, meaning it goes like that. Like that. It just reflects over. Now, A determines how skinny or how wide it is. The closer to 0, the wider, because remember, if it's lower down, it'll just make the values closer to the vertex, and vice versa, because it's very high. Like if you have 100A, it's going to be very narrow. H determines where it is horizontally. Now, this is hard to remember for many people, but you have x minus h. And if it's x minus a number, it moves to the right h amount. But if it's x plus h, it moves to the right. That moves it to the left h amount. Because if you think about it, it's saying if you do x minus h, then x has to be higher or farther to the right to get the same answer. Then k determines where it is vertically and affects the final y value. When you're done with this x minus h squared stuff, then you apply the k. That's how you do it. You use, order of operations. You do x minus h, then you square that, multiply it by a, and add k. And then you get y. Because if we think about what graphs and equations really are, it's if you're given some x value, what will the y value be, so we can find out the graph and find out specific points. Now, exit here. Now, since I said we were going to go over, don't mind those we'll use for later. Since I said I was going to go over one linear function, I'll just type in, let's see, f of x equals 2x minus 3. Let me go down over here and zoom in. Now, as we see, the y-intercept is -3, and we have 2x. So we go over 1, up 2, or up 2 over 1, which is just 2. Now, and if I made this over here negative, it would just reverse like this. It would go the other way, like that. The slope would just be down 2 over 1, and the y-intercept would be the same. Now, let's move on to quadratic formulas, or quadratic equations, functions. Now, right now we have f of x equals x squared. Now, it usually looks like this because all of the values are 0. When we go over 1, it's hard to tell because, let me make sure where we get to 1 block. Okay, if you go over 1, up 1, you'll find a point. It's going to be on the point of origin, which is 0, 0. Now, if we added an x minus h value, let's say we added x minus 3, that would move it to the right 3. Now, whatever value x needs to equal for x minus h to be 0, that's where the x value of the vertex is going to be. Now we see if x is 3, 3 minus 3 is 0, it's right there. Because it's x minus 3, and that point is at 3 right there. Now, this makes it easier to find the vertex. Now, let's say we do plus 4. This will help. This is all you need to know to find the vertex. You see it's x minus 3, so you know it goes over to the right 3 from the point of origin. And you see the plus 4, so it must be 3, 4, which is exactly what that is, 3, 4. Now, the trickiest part is the a value. We see on a normal one, it goes over 1, up 1. It goes on a normal, I don't know if you guys just saw that, but as you see, we have x minus 3 squared there, and then there's a plus 4, because if you have minus 3 and then plus 4, we go over 3, up 4 to find the vertex. Now, the a is the trickiest part. Let's say we put a 2 there, and it gets a little skinnier. And instead of having to go over 1, up 1, we go over 1, up 2. Because essentially what this is saying is the point is multiplied, whereas if we had put 1 in, we would have gotten 1 minus 3 is negative 2 squared is 4. Plus 4, we would have gotten, hold on, if we had x is 2, 2 minus 3 would be negative 1, squared would be 1, plus 4, we would have had 5 right there. But since it's 2, if we have x is 2, or f of 2, because see we have f of x there, if we substitute in that x right here for 2, then it just changes that x to 2. If we have it's 2, but we have the 2 right here, 2 minus 3 is negative 1, squared is 1, plus 4 is 5. Times 2 is 2, plus 4 is 6. Sorry, it's kind of late. So we see that 2 minus 3 is 1, squared is 1, times 2 is 2, plus 4 is 6. And then instead of having it 1 over up 1, we have 1 over up 2 at 6. But now if we did, let's say we did 0.5. If I did 0.5, it would get even narrower, and it would be over 2 up 2 instead of over 1 up 1. It would be over 2 up 2, because usually it would be over 2 up 4, because 2 squared is 4, but now it's over 2 up 2 because 2 squared is 4 and times 0.5 is just 2. Because we put in, let's say we put in 1. 1 minus 3 is negative 2. Negative 2 squared is 4. 0.5 times 4 is 2. Plus 4 is 6. So we should have 2 over, or 1, 6, which we have right there. So now, oh yeah, and if we make it negative, it just flips over that vertex, like I said there. It goes from a U to an N, like that. Positive, negative, positive, negative. Now let's get rid of that right now. Now if I look at this equation right here, let's say I look at this graph right here. I see that, boom, boom, it's negative 4 and negative 1. So I know the k value is going to be negative 1. The h value is going to be positive 4. So right now, off the bat, I know if y equals some a value, quantity x plus 4 squared minus 1. I see it goes over 1, up 2. That means that since it usually goes over 1, up 1, the y value must have been multiplied by 2, meaning that the a value is 2. So I have y equals 2, x plus 4 squared minus 1. Now let's look at the equation. I'm trying to find the graph. I see it's x minus 3 and x minus 2. So I know right off the bat it's going to be x, the vertex is going to be 3 comma negative 2. And then I see it's 0.25. So I know it's going to be a little wider. For example, instead of over 1, up 1, I divide those y values by 4. And it's negative, so I rotate it upside down. So first, usually you can just plug in a few points, but we're going to do proof of concept. Like usually you want to do x, you want to do 0, and then maybe 2 points. You can make them either positive or negative. I like to do 2 positive points. You don't have to do them positive and negative because you know the y value for the positive points is going to be the same as the y value for the negative points because you're just squaring it. That cancels out the positives or the negatives. So if I have y, I go over here and I see, oh, it's 0.25, meaning I must go over 4 or over 2 down, or I must go over. Wait, hold on. 1, 2, 3. Yeah, I must go. Oh, okay, over 2 down 1. Sorry. Over 2 down 1, because really if it goes over 2, usually that would mean that 2 squared is 4. But 4 times negative 0.25 is the same as 4 over negative 1, 4 over negative 4, or negative 4 over 4, which is just negative 1, meaning we go over 2 down 1. So then I could just graph it maybe one more time. I see that right there it's going to be negative 1, negative 6, because I know I'd have 4. 4 squared is 16. But since I have 16 times negative 0.25, I do 16 over negative 4, which is just negative 4. So now I end up moving over 4. 1, 2, 3, 4, down 4. 1, 2, 3, 4. Now if we let's say we just substitute an x for 2. 2 minus 3 is negative 1. Negative 1 squared is 1. Well, wait, we'll make it a little higher. Let's say you have x is 7. 7 minus 3 is 4. 4 squared is 16. Times negative 0.25 is negative 4. Minus 2 is negative 6. So we should have 7, negative 6, which we have right there. And now, also, one other thing about quadratic functions is that they're even, meaning their end behavior is the same. So both sides will either be positive or both sides will be negative. As we see here, it's going down on both sides, but if we make it positive, it's going up on both sides. It's never going to be it's going up on one side and down on the other. That's just not going to happen. Okay, then. That was all for my video. Please like and subscribe to help grow my channel and help this knowledge reach more people. And please turn on post notifications so we can embark on this math and science and any other thing you guys need. Your journey through high school. So you can watch my videos, understand the concepts, be able to do them well in school, and you can ace high school with ease. I'd like to give a shout out to my math teacher, Mr. Barrett, for teaching me all this information. And I'd like to say that when I'm done, hard math problems like in Algebra 2, and I fully understand the concept and I'm ready for the next day of school, I like to watch some great I like to watch video games on YouTube. Specifically, this guy, Mini Mindel, Mindel. Oh, sorry, wait, I don't know why I'm typing it there. Mindel. He's a YouTuber slash live streamer, and I just love to watch his videos when I'm done. So after you check out my channel, go check his out. And see, if you have any questions, comments, or concerns, put them in the chat. And all input is valued. If you have any requests, I'd love to take them. And yeah, that's it for my video today. I'm Scholastic Sam. Thank you guys. Bye. And always remember, knowledge is power.